Now we're going to learn about vectors. Now before we start with vectors, we would like to know what's the difference between scalar quantities and vector quantities. Now scalar quantity, they only have a size which we call magnitude. Alright. Vector quantities, they have both the size and direction. Now example of scalar quantity would be like mass. Say suppose 3 kilogram of sugar, we need not state any direction because the mass has no direction. Force is an example of vector because we need to know the size, say 3 Newton to the left, alright, and we need to know the direction. So other example of scalar and vector will be like speed, velocity, distance, displacement, and acceleration. Alright, now let's go on to something quite difficult for some. Now if we have two forces, two vectors acting on a small object, let's say a ball, two person is trying to kick the ball, so one at 3 Newton in this direction, one at 5 Newton. Alright, I've pre-measured this exactly at 40 degrees. Now what is the resultant force? Now it cannot be simply 3 plus 5 or 5 minus 3 because it's at an angle. So what do we know? We need to use scale drawing, that means draw to scale. Now I have already measure this. So what we need to do is to start with a reference point, okay, and then using a ruler. Now because 5 Newton, if I use 5 cm, is very small, so I'm going to use 10 centimeter. Alright, I'm drawing the arrow, give me some time. Okay, so I've drawn using the help of a ruler. This is 5 Newton represented by 10 centimeter. So every 2 centimeter represent 1 Newton. There is a scale. Alright, so this exactly like this. Now what about the 3 Newton? Now the common mistake is the students join the arrowhead to the arrowhead. So do not join arrowhead to arrowhead, which means that during drawing we need to shift the 3 Newton over to here. Alright, so at 40 degrees, so the angle must maintain the same. So I've pre-drawn here, alright, at 40 degrees. Alright, I've pre-measured. You need to use a protractor, alright, to measure exactly 40 degrees. It must be the same as the question. So I'm going to draw now. Alright, exactly at 40 degrees. Alright, and with a distance of 6 centimeter because I'm using a scale of 2 centimeter to 1 Newton. So now we have two forces, and you notice that the arrow is flowing. And now how do we get the resultant force, or we call the net force or the effective force? It has the same meaning. So if two person kick the ball this way, what is the resultant force on the ball? So we need to join from the start of the first vector to the end of the second vector, which means from here to here. Okay, I've joined from the start to the end, and you must indicate the direction, which means that now the direction is from here to here. And how big is the resultant force? Okay, it's 15 cm, so it's 7.5 Newton. Alright, so the answer is 7.5 Newton. if you are interested in the angle, you can actually measure this angle using the protractor. Alright, so we have clarified what is a vector versus what is a scalar, and we also learn how to add two vectors together using scale drawing. So we draw the 5 Newton, follow by 3 Newton, and join the head to the tail of the second vector. Then note you must have the direction of the resultant vector. So this is called the resultant force. Okay, the common mistake is student straight away join these 2 points. Okay, so do not join the 2 arrowhead. Okay, thank you for watching.